Hi, everybody. I'd like to talk to you about my ideas between STEM/STEAM, and if I had it my way, we would actually turn it into Shteam, which I'll talk about here in a second. But basically, we'll talk about our focuses, our models, and then I have some examples for you that maybe some of you might find very helpful moving forward with this. So, basically with STEAM or STEAM, here's our breakdown. So we have science, of course, which are hypotheses, understanding, all these different things that would go under our science curriculum. Here's our H, which is history. Now, I'm a social studies teacher, and when I first started our STEM models in my school district, I had a really hard time seeing, like, where do I fit in? Where do my students fit in with social studies? What do we do here? But I believe that every single STEM practice involves history because we are always looking at what happened in the past, what worked in the past, and where are we now based on what happened in the past, and that's history. And especially when we get into some local problem-based learning ideas, we're looking at our local civic design, and that also falls under history. We're looking at geography, we're looking at economics, so just hear me out here with the H. And it's way more fun to say STEAM, right? Way more cute. We have our technology. So with STEM or STEAM or STEAM, we are using technology to create, to find, to organize, to connect. With engineering, especially with what I'm going to be talking to you guys about next, which will be problem-based learning, we are creating an actual prototype, designing solutions and designing our own ideas as students. So we are engineering our ideas. Art, which definitely should be involved. Every single STEM activity I've ever used involves art. It involves creation. It involves creativity. And I can also say that this falls under language arts as well, which is the technique of language and presentation and rhetoric and propaganda, and all of that is involved because we don't just have students who have a STEM mind. We have students that are good at being presenters. They're good at coming up with ways to make something more appealing and unique to identify. And that all involves art and the language behind it. Math is our data collection, figuring out how we're going to work this in, our probability. So I'll be giving you some examples coming up of how I've been using Shteam in my own class and with my grade level team. And I'm just going to throw this out there, but we could also call it Smeeth. I don't know. It's a little cuter, a little more fun. I'm going to try. We'll see. Maybe in 5 years it'll be called Smeeth. So for my school district, we've been calling our entire STEM protocol for problem-based learning. According to my school district, project-based learning is not full on STEM. That's their opinion. So I have been working with project-based learning for a long time, problem-based learning, which is PBL. And our goal is that since 2016, every single grade level, every single teacher has used problem-based learning in our classes throughout the year. I've given you kind of a breakdown, the differences between project-based learning and problem-based learning. And basically, the main difference is that with project-based learning, it's more teacher-directed and students just kind of do what they think might be most correct on a grading scale. And then their end result is a presentation of some kind, and then it just kind of ends there. But with problem-based learning, we are really looking at what STEM is all about, which is there's uses of our 21st century skills. Students are analyzing, they're creating, they're developing, they're inquiring, they're inventing. And we are having students come up with a solution to a problem where there's no one answer. So depending on the student, they can find their own pathway of how they want to approach a problem. And usually this is like a local problem, and I'll give you some examples here in a second. And then the end result is presented to a panel of experts in this field, but it doesn't end there. With problem-based learning, we see a continuation in this solution process. And so the students really feel like they're part of something. And I think that's a big issue in school, is that students just kind of sit there and they're like, oh, what am I even here for? What's the point? But with problem-based learning, they are actually making something come into fruition, and they can see that progress as it happens. I have some breakdowns of STEM models in K through 12, and feel free to go and look through this. It depends on your school model and how you want to execute it. It's difficult if you're doing this individual versus school-wide. It depends on scheduling. I mean, we know as teachers, or even if you're in a different field, if we have to execute this type of practice, there has to be time allotted for it and a model that can accommodate it. My main thing that I love most about problem-based learning is that I get to work with my grade level team. Every single subject level is involved with problem-based learning. So it's not just science, technology, engineering, math. I see my science teacher, my math teacher, but then I'm working with the English teacher, I'm the social studies teacher, and we are all working together to make this happen. And students see this happening, and it serves as an example for them to know, okay, my teachers are finding a way to incorporate all of this content, and that kind of hopefully like makes it click, like, wow, the world really does involve all of these things. It's not just history, it's not just math. If I have the math, how am I going to write about it? If I have the science, how am I going to present it? Okay, so I like this team collaboration aspect. Here's the first example of how we have used problem-based learning in my classes. So our problem was local elections have a low participation rate. Nobody knows about local elections and nobody participates, and that's a problem. So our question, how do we get more voters to participate? So we have social studies, understanding the civic process, math, our data collection, science, our hypotheses, okay, what happens if we try this, or what happens if we try this? English, our use of propaganda and rhetoric, and then finally, art, create the panel project, create the presentation. And this can be done through video or a skit. I've seen students do all sorts of things. And this is also where we can involve virtual reality as well. The next PBL that's been successful that we've done definitely involved virtual reality. Down here at art, if you see, students created, I don't have access to this anymore, and I'd love to put on this presentation, but students created a before and after simulation for invasive species in our local city park. And this is like a real-time, real-life look before and after, and it worked, and it really made things effective. And what we're working on now, this is actually an idea that I have been trying to move forward, especially now with COVID, is health in our own school community. So how do we help with both hygiene, mental health? How can we make these practices happen over time? And so here's our breakdown of our different topics. I hope some of these were helpful, and I've had the issue of trying to figure out how does my subject level work into STEM. So if any of you are ever coming to that challenge, I have been there and I am still going through it. So I'd love to talk more about this. This is my passion. So thank you for listening, and good luck.